Hello there, so we're going to look at some projectiles. Projectiles are obviously where you project something or throw something or basically kick something from one place to another. And as this picture is trying to imply, I want you to be aware of a couple of things. First of all, to do this today, we're going to split it into two directions. We are going to be told the speed of an object, and we are going to be concerned from that initial speed, which we call u. We'll be told an angle theta, and we're going to need to know how fast that means it's going up and down, and how fast that means it's going left and right. So if we have a look at this here, we've got a picture here which is trying to show the motion. I've already drawn on the fact that this picture, for a start, it's got three different angles, and all three different angles produce different distances it travels. The thing you'll notice is it highlights the fact that on our picture it breaks the speeds down into up and down, left and right, and again that's what we're interested in. When you get given your initial velocity u and your angle theta, these aren't good enough, so we're going to have to use the fact that we resolve them, and we have these two resolved components. This one I'm going to call ux. This is the initial velocity in the x direction, and notice it's u cos theta. You might remind you of when you resolve forces. This is uy, and it's the resolved component of the velocity up and down. So just look out for this, u sine theta, u cos theta. And another thing I want you to be aware of is when it's moving, the ball will have two accelerations as well. The acceleration downwards is always gravity. This is always minus 9.8, and we call this ay. The acceleration in the y direction, it's always downwards because it's always been pulled back down to earth. But going across, actually, ax, there's no acceleration. Once I've kicked the ball, that's the end of it. I don't have anything else. So I want you to make a note of this. Draw a pretty picture, please, so that this is in your notes as well as all this. You'll need it all. An example for us then is that we've got a golf ball fired towards a hole at an angle of 50. So I always draw a picture. It's fired at an angle of 50 degrees. And it's got a u equals to 70. So the very first thing I do is ux equals, do you remember I said it was u cos 50? So in this case it's 70 cos 50. And if you do that, you get exactly 45. That's not exactly, but it's to two decimal places, it's 45.00. And the other one I want is uy. And up and down, so this is my ux going sideways. What I'm doing now is my uy going upwards. My initial velocity in the upward direction is 70 sine 50. And 70 sine 50 is 70 sine 50. Make sure you're in degrees, please. Press shift and set up, which is above the menu button. And I get 53.62. So now I've got those. It says find the ball's greatest height. Now the thing you need to know is the ball goes up and down. The greatest height occurs when it is, well, just thinking about it, the Vy, the greatest height, is when Vy equals 0. So if that's true, then what I need to do is to do suvat. I'm going to do suvat in the y direction, because my clue for the greatest height is when it's no longer got any velocity up or down, where Vy is 0. So I show these by just writing these with a y on. So I'm going to do suvat in the y direction. I actually don't care how, oh yes I do care, that's what I'm after. What is the greatest height? I'll put y there then. The uy, I actually know what that is already, it's 53.62. And the other thing I know will happen at the greatest height is the Vy, its velocity in the upward direction, will be 0. I've already said that ay is minus 9.8, it will always be that, and I actually don't care about the time. So this equation that I'm going to use is v squared equals u squared plus 2as. These are equations we've seen loads of. So therefore 0 is 53.62 squared plus 2 times a, which is minus 9.8, times y. Well, 2 lots of 9.8 is 19.6, so I move it over to the other side. 19.6y equals 53.62. So my answer squared is 2875. And a bit. And to get y, then I have to divide by 19.6. And I get 146.7, or I'm going to call it 147 meters to 3 fix. The other things I want the time taken for the golf ball to return to the ground. So over here then, let's just draw a picture. It returns to the ground. Notice when y is 0 again, it starts off with no height and ends up with no height. So this is the rule that we're going to use for how far does it go. It returns to the ground when y equals 0. So if that's true, then just thinking about it for a moment, we can use SUVAT again in the y direction. S-U-V-A-T, and notice I label all of them apart from t with a y. So sy, well, that I don't care about, do I? Does it say how much time? Yeah, the time it takes to do it is what I'm after. AY is still minus 9.8. I think this was 53.62. Y actually is 0. That's what I need. That's the one I don't need. Now, what equation is this? This looks like, to me at least, S equals ut plus a half at squared. You'll need to know these formulae, of course. So I can write 0 equals u, 53.62, times by the t, which is what I'm trying to find, minus a half of 9.8. Well, if you half 9.8, you get 4.9 t squared. And again, this is an equation I can solve. Now, you could chuck it into your calculator to do it, or you could just factorize it. And if you take out t as a common factor, you get 53.62 minus 4.9 t equal to 0. So t is equal to 0. Well, t is equal to 0 is here. That's not the one I want. Or this lot equals 0. Or put a different way, 4.9t equals 53.62. And I'm going to divide that by that. So I get 53.62 divided by 4.9. And I get 10.9. After well, it's actually 10.94. I'll be a bit more precise. 10.94 seconds, it hits the deck. That's a big old shot, I think. And what's the final question? It says the distance travelled by the golf ball. Well, fortunately, we've already found out how long it takes to fly that far, 10.94 seconds. The next thing I want to know is how far it goes. We call this x. What's that distance x? So actually now I'm going to use SUVAT again. You'll be thinking, well, that's exactly the same as last time. But this time I'm going to do it because I want x. I'm going to do it in the x direction. And notice all of these things now change, apart from t. T is the one thing that stays the same, which is lucky because I've just found that it took 10.94 seconds to do it. I also know that AX is 0. I said that before. AX is always 0. What do I know? X is what I'm after. The SX is, we're writing x. And I think I called this 45.00. In actual fact, that's the one I don't know. So this is SUVAT again. This is S equals ut plus a half at squared again. And if I put these things in, I get x equals. Well, the one thing to notice is because that a equals 0, all of that will disappear. So it just becomes 45.00 times by 10.94. 45 times by 10.94 equals, I get 492.3. So I'm going to say 492 meters. Yes, yes, and yes. Good. Second question. A rugby ball was passed from the ground with a speed of 7. Okay, it's passed on the ground, speed of 7. So there it is on the ground. It's passed with a speed of 7 and an angle of 60 degrees. Again, straight away I'm writing ux, uy. What are those components in those directions? And it's 7 cos 60 for ux, and it's 7 sin 60 for that one. Now, cos 60 is a half, so I can do that one quite easily. 7 sin 60 is not so obvious. And it's 6.062. So now I've got that, it says, what is the height of the ball above the ground when it is caught? And notice it says here, it is caught at the point P 1 second after it's passed. So effectively it's going to fly through the air, and because I want the height of the ball above the ground, that's in the y direction, that's up and down. So I'm going to write SUVAT again. You'll get used to writing SUVAT, but this is in the y direction. t doesn't change. But t, luckily, is 1 second. They've told me that already. AY is always minus 9.8. What else have I said? UY is 6.062. And I want the height of the ground. This is what I want, y. So that's one I don't care about. So which equation? This is s equals ut plus half at squared again. You'll get good at these equations. So y equals, what was u? It was 6.062 times by 1 plus a half. Again, notice it's a half of minus 0.8 again. So I think that's minus 4.9 times t squared, which is 1 squared. So what is y equal to? It is that minus, well, effectively minus 4.9. Oh, let's do that again. 6.062 minus 4.9. And I get 1.162. 1.16 meters then. And then it says, if instead the ball is not caught, find the time it takes to reach the ground. Okay, then we'll do this on the next slide. Now, the time it takes to reach the ground, of course, is, well, we've just done a question like this. This is when y equals 0. So again, I'm going to end up here doing suvat. But I'm going to do suvat in the y direction. Sometimes it's the x, sometimes it's the y. Here I'm just going to say y equals 0. The uy was 6.062. Vy, actually I don't think I care about that. Ay is always minus 9.8. T is what I'm after. This looks like to me s equals ut plus half at squared. So 0 equals u, 6.062 times by t. Half of a is, again, 4.9 minus 4.9 t squared. So if I take out t as a common factor again, I get 6.062 minus 4.9 t. So either, this is equal to 0 of course, so either t equals 0 from this bit, or I think 4.9 t equals this if you rearrange that equation. So I think t is that divided by that, and if I quickly type it, I get 1.24 seconds. See if the answers are right. 1.24 seconds, and 1.16 looks right as well. Now I've got a third question. I don't think we'll get through it all, but I can make a start on it and perhaps finish it in class. We've got a cannonball fired at 30 degrees, 90. So again, my initial thoughts are I want ux, that is 90 cos 30. And uy will be 90 sine 30. Notice this, it says assume g is 9.8. I think we do that all the time in maths, unless they say something otherwise. And that's 90 cos 30. In physics they use 9.82 usually. 77.9. So 77.94. There you go. And sine 30 is a half, so I know that one's 45. Find the time at which the cannonball reaches its greatest height. And we've already seen its greatest height occurs when Vy equals 0. So if that's the case, well, I might as well do suvat again in the y direction. So this is y, 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 y. And it reaches its greatest height. It doesn't care what that height is, so Vy is 0. Ay is minus 9.8. The uy was 45. And as I say, I don't care what that one is. I want the time instead. So what equation? I think this is v equals u plus at. So v is the 0 equals 45 minus effectively 9.8t. So I think 9.8t equals 45. I do 45 divided by the 9.8 then. It gives me 4.59. That's how long it takes for it to hit the deck. Now we're not going to finish this. So we've got these two questions to do. 4.59 was right, by the way. And I want to just show you this. These are a bunch of rules that I want you to copy down into your notes. It says, find the time taken to reach the maximum height. We're going to use Vy equals 0. You want the maximum height? Use Vy equals 0 to find this Sy. Find the time taken to reach the ground again. There's 2 steps. Find the range. There's probably 2 steps there as well. Now, copy that down. That'd be very, very useful in class. And we will then do these questions. But notice I've got one question to finish in class as well. But do make sure you've copied down all these little tricks, and these are very useful tricks in class when you're dealing with projectiles. Thank you very much.